Imagine standing on a rocky ledge in the Catskill Mountains of New York while a quarry wind lifts the smell of wet stone and fern. At your feet are fossil tree stumps so broad you could eat lunch on them. I tell you the simple, astonishing thing we are looking at, the moment the world invented wood. In the late Devonian, around 380 million years ago, plants like Archaeopteris rose above the ground in pillared groves. They built true trunks with tough fibers and plumbing that could lift water the height of a house. Those fibers, mostly cellulose bound with lignin, added a toughness earlier plants did not have. Wood is a biological armor that resists bending and decay, and once evolution discovered it, height became a reachable dream. Archaeopteris made rings, produced timber, cast shade, and sent roots deep into the new soils of Earth. It was a spore plant, not yet a seed tree, but in almost every other way it looked like forest you know. I first learned to read these rocks from Dr. Lena Brooks, a paleobotanist with sunburned freckles and a patient voice. She jokes that plants are the quiet engineers of history, shaping the stage without applause. On our first day at the quarry, she brushed a hunk of mudstone with water and showed me a leaf imprint as fine as lace. Then she traced a line with her finger from trunk to root to the lens of sand that marked an ancient stream. Wood, she said, did not simply let trees be tall, it tied landscapes together. Before forests, rivers were often broad and braided, their banks loose, their bars sliding with every flood. Once roots took hold, banks stiffened, mud settled, and water began to curve into stable meanders that built floodplains. A tree is a tower? Yes, but it is also a clamp that holds the ground in place. When the ground holds, you can build ecosystems on top of it. Fungi digest fallen logs, millipedes and early insects crawl the leaf litter, amphibian ancestors haunt shaded pools. Every fossil here is a receipt for a transaction between biology and geology. Note where is the bill larger than with wood, the ultimate ecological investment. Inside a trunk, tubes called xylem move water upward, and phloem moves sugars down. Wood is mostly old xylem walls reinforced with lignin, a chemical puzzle most Devonian decomposers could not solve. So forests banked carbon in their bodies and in their soils, and some of that carbon was buried. Dr. Brooks compares it to a planetary savings account built over millions of years. Each growth ring is a deposit. Each storm-toppled trunk in an anoxic swamp is a certificate of deposit. Over time the balance grows, and the climate changes in measurable ways. As forests spread across Laurussia and Gondwana, atmospheric carbon dioxide declined. Global temperatures began to cool as the air itself changed taste. Rivers cleared, and weathering of fresh rock accelerated under the work of deep roots. Roots fractured bedrock and pulled nutrients upward to feed the green canopy. If you think of trees as scenic background, Devonian wood teaches a harder truth. Life can redraw the map of physics at the surface of a planet. In the lab, thin sections of Archaeopteris tell the story with microscope beauty. Orderly rays, sturdy tracheids, growth rings swelling with wet years and tightening with drought. A diary written in tubes that span centuries in a single trunk. Once you see those rings, you can imagine whole summers of wind crossing fern plains. Raindrops through green roofs, and trunks earn each centimeter of height. I remember crouching at the base of a fossil stump while a thunderstorm climbed the ridge. The smell of petrichor was so strong it felt like time had folded. For a moment the quarry filled with phantom trees in imagined motion. We talk a lot about dinosaurs when we talk about deep time. But the quiet, decisive revolution was earlier and greener in its reach. Wood is the technology that taught land how to hold itself together and reach upward. Archaeopteris did not do this alone. Cladoxylopsids grew strange pipework trunks. Lycopsids rehearsed the skyscrapers of later coal swamps. Roots of many lineages stitched sediments into place against floods. But Archaeopteris was a master generalist, colonizing floodplains and hills alike. It thrived in well-drained soils, casting broad crowns that altered wind and light. It made forests feel like forests in structure and community. When we map its fossils today, we see a belt that girdled continents, a living architecture that turns scattered groves into regional biomes. Standing here, you can lay your palm on a sandstone cast of a root. You feel the outline of a decision evolution made hundreds of millions of years ago. Invest in lignin, invest in height, and open new space for everything that follows. Trees are not passengers in Earth history, they are drivers with hands on the wheel. Wood was the key that fit the ignition for the forested world we know. Not far from here, at Gilboa and near Cairo, geologists mapped ancient root systems. They supported a mosaic of trees in some of the oldest forests known. Those sites were frozen mid-growth by floods that entombed their bases in stone. When you ask how a grove of trees can cool a planet, I sketch the carbon cycle with the tip of a field pen in dust. Forests pull carbon dioxide from the air and weld it into sugar, starch, and wood. Some returns to the air when leaves respire or when logs rot, but not all in the Devonian. Few microbes could fully dismantle lignin, leaving more carbon stored for longer periods. Roots pry into fresh rock, breaking silicates and freeing ions to travel with the rain. Rains carry those ions to the sea, where they help build carbonate minerals that lock away carbon. Meanwhile, organic detritus washes into quiet basins and settles under low oxygen waters. There it forms black shales, rich in ancient sunlight and preserved in geological time. Each of these threads tugs the same direction: less carbon in the air, cooler temperatures. The first long flirtations with ice arrive on Earth's evolving stage. Cooling does not arrive as a gentle lullaby. It comes with jagged seasons and altered currents. Life responds in uneven ways to these sharp environmental changes. In some late Devonian intervals, coral reefs falter and oceans grow stratified. Parts of the seafloor turn anoxic, and fishes and reef invertebrates decline in pulses. Plants and freshwater lineages advance inland to exploit new opportunities. You can read those stresses in layered shales like a heart monitor. Spikes of darkness record moments when oxygen vanished from the water. Downstream from the first forests, channels begin to meander more gracefully than before. Floodplains widen and soils thicken into layered horizons full of life. On those new stages, arthropods and amphibian precursors find shaded refuges. They enjoy cooler days and reliable pools in complex new landscapes. A landscape with trunks changes how wind moves and how rain falls. It changes how fire behaves, splicing time into seasons and droughts. It trains animals to live in edges where habitats meet and overlap. On a later trip, Dr. Brooks and I joined a weekend quarry clearing crew. Volunteers ranged from retired teachers to a teenage wildlife artist named Cameron. Cameron sketched fossils between shovel passes, carrying a sketchbook like a life raft. He drew not only the plants but the spaces between them. Dim aisles, light shafts, and the clutter of fallen branches that becomes habitat. In his drawings, the forest is an instrument and the animals are the music. That weekend, we found a mat of root traces radiating like spokes. Dr. Brooks showed Cameron how root density maps moisture in ancient soils. She explained where small animals might have hunted during dry spells. We spoke of early tetrapods nosing along such shaded banks, of fishes that needed shade for ambush and insect lineages testing richer air. Forests give options, and options are the raw material of evolution. But options for one group can mean limits for another. When nutrients surge into seas, algae bloom and oxygen plummets. Creatures needing clear, stable water suffer under those new conditions. The lesson is not that trees are villains, but that power in nature is never solitary. Plants, microbes, climates, and continents bargain constantly with each other. When one partner changes the terms, the others scramble to adapt. If this sounds familiar, it should. Our own century is a crash course in unintended consequences. Devonian forests were not endless walls of pine as some imagine. Archaeopteris bore fern-like fronds, reproduced by spores, and grew in patchwork stands. They crept outward along rivers and deltas in a mosaic of habitats. Between groves lay open ground and wetlands inviting ecological experiments. In those edges, you can imagine armored fishes in weedy backwaters, eurypterids skulking under logs, and the first true soils forming. The magic of wood is that it multiplies contact across Earth's surface. More leaf surface to catch light, more root surface to taste rock, more trunk surface to host fungi and invertebrates, more roughness to slow wind and water. Multiply that by millions of trees across continents, and the planet's skin gains drag and memory. Storms drop more water locally and rivers remember their banks. Carbon remembers the darkness of buried mud in deep geological time. On Sunday evening, Cameron handed me a finished piece of art, a Devonian river bend under a vaulted crown of Archaeopteryx in green light. A ripple of fish in the shallows and a small amphibian ancestor peering from a root tunnel. Dappled light moved like coins across the water in his drawing. He had written a caption at the bottom of the page. The forest is not a place you walk through, it is a thing that walks with you. His words stayed with me as we packed the field gear for home. Once wood appears, you do not simply add trees to a list of species. You add a system that makes new systems possible and expands time itself. Deeper soils, longer-lived organisms, thicker food webs, and feedbacks that echo into oceans and ice. Back in town, an engineer named Marcus runs talks using sand to show rooted banks. He tells audiences that trees teach water to remember, and memory leaves stripes in stone we can still read today. If part 1 was wood rising and part 2 was wood reshaping air and water, then here is the payoff: wood changing the path of animals, including us. Picture a late Devonian delta at dusk, a web of channels and point bars stitched by roots. In the shallows, lobe-fin fishes lie in wait for prey that wanders too close. Along the slack water edges, creatures with wrists and toes test water against mud. Forests make banks, banks make edges, and edges are where transitions unfold. It is no accident many early tetrapod fossils come from vegetated floodplains and lagoons. Trees built the corridors and shelter that let experiments take shaky steps toward land. You can imagine a juvenile fish stranded in a shrinking pool beneath overhanging branches. It gulps at humid air, fins fanning against wet leaves in the fading light. Survival in that moment rewards bodies that can prop, pivot, and breathe in new ways. Archaeopteryx did not invent lungs or fingers, but it nudged probability toward them. By cooling summers, stabilizing soils, and diversifying habitats, forests tilted the odds. When we teach this, timelines often flatten the drama into dates and arrows. I prefer to tell it as rooms in a house that trees built long ago. Each room has its own light and floor, each one hosting a different guest. One room carries soft silt for burrowers seeking safety from predators. Another collects leaf litter where small hunters wait in ambush for passing prey. Another opens to a sunstrip where a fish can warm before slipping back to shade. Evolution enters each room, looks around, and tries the furniture for fit. A city tree is not a decoration, it is a pump, a shade engine, and a noise sponge. A riparian forest is not a postcard, it is a flood manager and a fish nursery. A peatland is not wasted land, it is a slow archive of carbon and water. Second, we remember that power requires companionship to function. Devonian forests thrived with fungi, soils, and rivers as partners in design. Modern forests need microbes, pollinators, predators, and patient, curious people. The third answer is to act where you stand, starting close to home. Plant trees. Yes, but plant the right trees in the right places for success. Protect old growth where it survives, and let rivers touch their floodplains again. Keep wetlands wet and learn the names of species holding your region together. A paleontologist can tell you what worked once. A community can test what works now. I also told Cameron something harder and less romantic to hear. Nature's big wins have big side effects, so humility is better than triumphalism. The first forest cooled the air but pushed seas toward low oxygen spales. Life adapted, but not without significant losses along the way. Our task is to move carbon quickly in the other direction with care. We must do it without breaking the systems that feed and shelter us. If trees once changed the planet by accident, we must do it on purpose. We packed our field jackets and walked back through the quarry in the evening. Swallows sketched tuning forks in the sky above the ridge. On the talus, fossil bark pieces flashed their diamond patterns in the low sun. In a shallow puddle, a dragonfly hovered over ripples shaped like ancient roots. I thought about how often wood has taught us the same lesson in different forms. Invest in structure and you gain stability and reach across landscapes. Invest in connection and you gain resilience against change and disruption. Invest in time and you gain possibilities invisible when you began. The Devonian forests did all three and paid returns to armored fishes and pioneers. Ultimately, those returns came to us walking here much later in time. We are not the first to walk beneath a canopy and feel our thoughts get taller. We are, however, the first to read the canopy with isotopes and thin sections. And the first to wield chainsaws at the same moment of insight. That mismatch of knowledge and power are the hinge of our own story. The story lands best when it moves from fossils to futures in a single breath. The measurable part is good science. The felt part is belonging to the world. Belonging is what would grant it to land life, a fabric to hold and climb. A place to hide in, live in, and remember across generations. As the sun set on our last day, Cameron spoke of studying landscape architecture. He wants to draw forests into places that need them most. Dr. Brooks grinned and said he would be joining the same guild Archaeopteryst began. A guild that practices patience, catches light, and turns wind into biography. If you carry nothing else from this story, carry this truth forward. The trees that invented wood did not merely decorate the Devonian landscape. They engineered a cooler, more intricate world and invited animals to try land. That invitation is still open, and the work it began is not finished. We live in the long aftermath of a plant's decision to harden its walls. Our best future will come from honoring that decision with care and curiosity. We must see forests as partners rather than props in the story we share.